there, good there. All right.
Bill's real cool.
All right, hey, I'm going to have you start with the third page actually today of your notes. So we're going to kind of jump around. We're not necessarily going to cover everything that's in here. We'll be kind of jumping around a little bit, but some important things in here. But I do want to start on the third page of your notes here. We're going to start looking at solving inequalities using addition or subtraction. This should be very simple. Again, another pretty easy section. Remind me of inverses for solving equations again. Inverse of addition, and then the inverse of subtraction would be addition. So you guys know this, all right? As we talk about solving inequalities today, we're going to run into a situation where we have what is called equivalent inequalities. And what you need to know about equivalent inequalities is the following, all right? They will be inequalities that have the same solution. Will be inequalities that have the same solution, all right? And we'll come back to this right here, but I at least want you to get the vocab down first. Okay? They're going to be inequalities that have the same solution. So if the answer to one is x is greater than 5, and the answer to another one is x is greater than 5, we would call those two inequalities what type of inequalities? Equivalent. Okay, they'd be equivalent. All right. So, anybody need more time getting that down right there? Got it? Okay, let's run back to the first page here quickly. Okay, we're not going to do too much with the exploration right here, but again, our title today that we want to deal with, solving inequalities using what, kids? Addition or subtraction. Okay. Question I want to ask there, the question that we're setting out to try and answer is how can you use addition or subtraction to solve an inequality? Okay. I'm not really going to get into this too much down here, but I think we can figure some things out. Where are my football players at? Okay. Let's kind of talk through this a little bit. It says the NCAA uses the following formula to rank the passing efficiencies of a quarterback. Okay? The passing efficiency is given by P is greater than 8.4 times Y, 100C. I don't know what the notation on some of this stuff is here, but let's just talk about this right here. What's Y represent? What's Y represent? What's it say it is here, kids? Okay, so it's the length of all passes. It's the number of yards. Y stands for yards. T is the number of what? Number of touchdowns. A is the number of attempts. Okay. It says C is completed passes. N represents intercepted passes. And M represents incomplete passes. And they ask you some questions about this, okay? A quarterback drops back. He starts throwing. One of three things is going to happen if a quarterback throws the football in a game. What's one thing that could happen, kids? He throws the football. The ball might be completed. Somebody catches it, okay? Or he might throw it to the wrong team, which they call an interception, or it might be incomplete. So if a quarterback throws the football, one of three things is going to happen. He's either going to complete it, intercept it, or incomplete. Now, if the ball is completed, it's either a gain or a touchdown. So it's either a touchdown or not a touchdown. Okay? Down here, we want to determine if stuff is true or false. Okay? And I think we can figure this out just kind of by logical reasoning here. So it says determine whether each inequality must be true and explain your reasoning. Here they're saying T is equal to what, kids? C. So what did T represent again, kids? Touchdown. And C represents what? Now here's the situation. In order for something to be true, it must be true every single time. So they're saying right there that the number of touchdowns is equal to the number of completions. Could it happen? Yeah.
Why does ours say less than C?
Does it say less than?
Mm-hmm.
All right, let's fix that. All right, let's fix that. I don't know why that does that. Is there a less than on the notes there for you guys? Okay, let's fix it. Okay, so it says the number of touchdowns is less than the number of completions. Is that true? More than likely. Okay, more than likely, right? Okay, so I would say it's true because not all completions are what, kids? Not all completions are what? Not all completions would be touchdowns. Okay. All right. Gavin, is that right on part B right here? C plus N is less than or equal to A. Okay. So C plus N. C plus N. The number of completed passes and the number of intercepted passes has to be less than or equal to the number of attempts. Okay? Well, here's the deal, guys. You're going to have basically a lot of attempts. Some of your attempts are going to get completed, some are going to get intercepted, some are going to be incomplete. So is this statement going to be true or false? The number of completions you have plus the number of interceptions you have has to be less than or equal to the number of attempts you have in a game. How many say that's true? Remember, some passes are going to be what? Some passes will also be what? Incomplete, okay? Every attempt that I make, I might throw the ball 50 times in a game. Is every single one of them going to be caught? Probably not. So the attempts is going to be the highest number, okay? What we're really saying is all three of these numbers right here, this column right here has to add up to this right here. So if I'm talking about just two of the three right here, won't the number of completions plus the number of interceptions have to be less than this? It would, wouldn't it? Okay, so I would say that this is going to be true also. Okay. All right, let's look at the next one. I'm not going to worry about part D. Is there a sign in here besides equals? What is it? Less than. Okay, it says the number of interceptions is less than the number of what? Attempts. If I throw the ball 60 times, am I going to throw 60 interceptions? If I do throw 60 interceptions, coach better do what? Bench me, bring in the backup, right? Okay. Call me Brett Favre if I'm throwing 60 interceptions, isn't that right? Isn't he the all-time interception leader of all time? Where are my Packer fans? Who are my Packer frisbee? Isn't Brett Favre the all-time interception leader in the history of the NFL? I don't know. He threw a really bad one when he played for the Vikings. 2009 NFC Championship, thrown across his body. All he had to do was run out of bounds, think the Vikings go to the Super Bowl, but no, he throws an interception. I'm convinced to this day Brett Favre was still playing for the Packers that day that happened. All right, anyway, this has to be true also because for every attempt I have, not every attempt is going to get intercepted, okay? Not every attempt would be intercepted. Okay. So they talk about this stuff right here in terms of quarterback ratings and stuff like that, and they ask questions about, well, if a guy throws 50 times, we would assume that out of 50 throws that the number of touchdowns he would throw would be less than the number of attempts, or we would assume the number of touchdown throws would be less than the number of passes he completes, stuff like that, okay? So not a big deal here, but what I do want to do is this. Just kind of talk about where this stuff shows up. I'm going to jump over to page 2 right now. And on page 2, kids, I really just want to kind of talk about this down here. Okay, I've got some funky stuff going on here, so I'm going to kind of read these in here as well. right here, number 3, how do you use addition or subtraction to solve an inequality? We already talked about this a little bit. The inverse of subtraction is what? Addition. And the inverse of addition is? So to answer this question today, how are we going to solve this right here? It says, how can you use addition or subtraction to solve an inequality? Here's what I want you to write. You can say we can use addition or subtraction to solve an inequality by using, what's the word I'm going to throw up here? Starts with an I. Inverses. Very good, kids. All right, so let's take a look at this. This should say x plus 3 is less than 4 right there, okay? Now, if I wanted to go ahead and solve this right here, anytime there's an inequality sign, that's really taking the place of an equal sign, okay? And if I wanted to isolate x right here, what would you have to do to both sides, Dad? Well, I thought you were raising your hand, but you were just stretching, weren't you? Do you have an answer? Subtract how much, kiddo? 3. Exactly. Okay, so subtract 3 from both sides. Boom, boom. Okay. So on the left side, what are you left with again, kids? X. Okay, now anytime you're dealing with inequalities, don't switch stuff around. Keep what's on the left, keep what's on the right. Bring your inequality sign down. If you're like me, and this is going to happen, we're so used to putting not an inequality sign, but we're so used to writing equal signs, right? It's going to happen. You're going to make a mistake, but make sure you bring the proper sign down. What sign should I bring down? Less than, you bet. Less than. What is 4 minus 3? 1. Okay. Solving inequalities is just like solving equations when you undo addition or subtraction. Okay. You're just using inverses. So I know mine looks a bit different. What I'd like you guys to do quickly, try B, C, and D. Get your x value alone. Tell me what you have for a solution. All right, who needs more time? B, C, B. All right, real quickly on B. I don't want to spend a ton of time on this. I want to give you some time to get some things accomplished today. What do I have to do? Add 3. So in this case, somebody read the inequality. Read it variable sign number for me. How is this going to look when you're done with part B? X. X is greater or equal to 8. Give me a show of hands. How many have that? Excellent. Excellent. How about a volunteer to talk me through C? What do you have for part C here? Gavin?
Add 2 to the 4.
Okay, so what do you have on the left side?
X is less than 6.
Okay, so I really agree with that. X is less than 6. Did anybody just add the 2 and then just put 6 on the left and call it greater than X like this? Okay, and that's okay. 6 is greater than X, but Gavin says, you know, I don't like my variables on the right side. You put it on the left. So he took the X and the 6 and did what, kids? Switch it around. And if he switched the variable and the number, what happens to the orientation of that inequality sign? What direction? What do you do with direction? Okay. I'm going to say that this is also X is less than 6. That's what Gavin said. Gavin, very good. Okay, last one quickly. Matthew? Okay, minus 1. So you'd have negative 3 on the left. Bring my sign down. Very good. How many wrote it like that? Negative 3 is less than or equal to X. How many did what Gavin probably did on this one and wrote X is greater than or equal to negative 3? I'm assuming that's what you did. Okay. Very good, guys. All right. This is not tough stuff, is it? Okay. We're going to kind of jump around here again then. So go back to this idea of equivalent inequalities on page 3, right up here, just to make sure we understand what the heck we're even talking about. I'm going to write something like this. Let's write x plus 7 greater than 11. And let's write x minus 2 is greater than, oh, let me think, positive 2. Okay? If I solve this on the left right here, kids, what do you get? X is greater than 4. If I solve this over here on the right, what do you get? X is greater than what? 4. What do you notice about the solutions for these two inequalities right here? They are exactly the same. So the question is going to become the following. Are these two inequalities right here that I just circled, are those inequalities equivalent or not? Yes. And the reason they're equivalent is because the answer, solution in this case, turns out to be exactly the same. They didn't look the same to start with, did they? But when you solve them, solutions are the same. So that's what it means to have equivalent inequalities. When you start with your inequalities, you solve them. If your solutions are the same, then you would say that's an equivalent inequality. Okay? I don't know how to make this much easier than what we're doing right now. Okay? Well, I do. We could make it a calculus class today. Should we start calc? Derivatives, antiderivatives. Find the value of irregular figures by slicing using Riemann sums. No? Not yet? Later? No? Okay. Hey, jump ahead then. 4th page. I'm going to completely skip the 4th page of notes. I think you can read through those and figure that out. So I want to jump to the last page, page 5. A couple of examples I really want to hit hard here. I want to hit number 3. I think that would be a good one to talk about. I also think we should talk about I think we should also talk about, say, number 6 there, and then number 7. So I want to circle these here, okay? I don't know what's going on with my formatting here today, but I'll get the right stuff written in there. You at least have the right paper in front of you. Kids, right here, solving this right here. Guys, just a quick refresher. You're going to see inequalities that look like this, and then they're going to ask you to graph this, and they give you a number line. It'd be pretty simple to do. First of all, they start throwing a curveball when they say s minus negative 1. Subtracting a negative is the same as actually doing what? So we may need to rewrite this first and call it s plus 1 is greater than or equal to 2. Okay? So when we solve that, then what do we get for a solution? S is greater than or equal to how much? 1. Okay? So graphing this. I don't care where you start. I have absolutely no idea. What I do care about is this. 2 things. Where you start, make sure you label a value. So what value are we referencing in our solution here, kids? 1. I'm going to pick my line and say 1's right here. Okay? I don't care where you put it. The next part then is the following. As I reference 1, should we include 1 with a closed dot or leave it open and say it's not included? Closed dot. So closed on 1. Okay? And then give me some values that are greater than or equal to 1, kids. And where does 2 lie in reference to our 1? So which way am I shading for this? To the right. Okay? So you might see some stuff like that today. And that's, again, I think that's something that's very simple. You should know how to do that. Okay? All right, 16 is just a terrible mess down here. Looks like Spanish class today. So let me rewrite this. This says 15. Maybe I can get away with it. This says 15 minus 7p, doesn't it? Plus 8p is greater than 15 minus 2. Okay? Now, I think we know how to handle this, but thoughts? What do you guys think in terms of how to start this? Again, we're solving for p. We want to solve this inequality for p. Thoughts on how to start? Looks a little bit longer than things that we've looked at. Gavin, what do you think, buddy? Okay, so what would the left side look like first? And what is negative 7p plus 8p? Lou, careful. Negative 7. If you start negative 7 and then add 8 more.
1.
Yeah, 1p, right? So this is like 15 plus p is greater than, what do you want to do with the right side, kids? Call it what? 13, okay? Get it to a form that we're comfortable with, a variable plus another number. Now what are you going to subtract from both sides, kids? Subtract your 15, and you're going to end up with p greater than what, kids? -2, okay? So reference -2 somewhere. I don't care, I'm just going to choose -2 here. Open or closed on -2, kids? Open, right? Left or right? Going to the right. We want to be bigger than -2. There it is. Okay, there it is. All right. Basically, guys, if you can add and subtract, and you know open and close, and you know your left from your right, that should be pretty gosh darn easy, shouldn't it? You don't know that? You watch NASCAR? Darn, I can't even tell you they turn left all the time. That's not going to work. Just do this. Or do the L thing. Left. Right. Okay. All right. Last example right here, kids. It says you have how much money? $15 to spend on groceries. You have $12.25 worth of groceries already in your cart. Part A says write an inequality that represents how much more money M you must spend on groceries, or you can spend on groceries. How much have I spent already, kids? $12.25. Now we can spend some more money, which I'm going to say I can add more money to this, so I can spend some more, but I can't spend so much that we go over what value?
15.
Okay, so I want the $12.25 that's in the cart plus the amount more that I can spend. I want that total amount to be equal to 15 or less than that. I want what I've spent plus whatever else I'm going to buy to be less than or equal to the amount of money I have in this case of what? $15. Okay? Now, again, modeling problems right here should look very similar to the ones we're looking at solving. Does this look like I would have to use addition or subtraction to solve this right here? Yeah, what are you going to do with both sides here? Okay, so you're going to go M and subtract 12.25 from this, and when you do that, how much more can you spend? Well, you can spend up to how much, kids? Okay, if I spend $2.75 or less on my remaining materials, or my remaining whatever I'm getting at the store, you'll be okay. All right? Questions about what's going on here? Last section, very easy. This section, very easy. So make sure we're completing stuff, getting that stuff done. Don't forget about your deadlines with